Alright class, in this lesson we're going to take a look at logarithms. And logarithms are the inverse notation for exponential functions. So this is our exponential function we were looking at last lesson, and this is the logarithmic way of looking at it. Notice the x and y are in opposite places as they were in the exponential graphing section. We had it was y equals b to the x power. Notice it's traded places because again this is the inverse way of looking at it for logarithms. And a logarithm is defined as being y equals log. You have a base, b, and x. Now the technical way of saying this is log base b, because the b is actually the base, of x. Okay, that's the way you say what you're looking at here, log base b of x. Okay, now you've got two identities. This one, this is log base b of b to the x power. Whenever you have a base that is the same as the number that's right here, so it's log base b of b, when it's the base and what you're taking it of are the same thing, like they are here, then whatever the exponent is on the number, that is the actual answer of the logarithm. Okay, so if I had something like log base 2 of 2 to the third power, the answer would be 3. So if these two numbers are the same, whatever the exponent is, it would be a 3. Now let's say it was log base 2 of 2, just like that. Well, the answer is 1, because there's actually an imaginary exponent of 1 right here, even if nothing is written there. Okay, so you got to watch out for those types of tricks. Now we've got the same rule applying. If bases are the same, the exponents will be equal to each other. We worked on that last lesson. Okay, now going logarithmic, we've got something that's exponential, and we had our rule from last lesson that if the bases are the same, then the exponents have to be the same. And here you could rewrite this to be 2 to the third, and yes, 8 is equal to 2 to the third because I could rewrite 8 as being 2 to the third. But that's not what we're concerned with in this lesson. In this lesson, we're concerned about rewriting this in log form. What we do is we have a circle pattern, and we could use this formula, but I feel like that's a little bit of a longer way of going. What I do is I try to have my students start at the base, whatever the base is, that's being raised to the exponent. See how the 2 has the exponent, and the 8 does not have a number exponent other than 1. So we start at the 2, and so that's what we write first. We are log base of 2. Okay, and then what we do is we go to the other side of the equal sign and draw an arrow. So log base 2 of the next number, so after the of is 8. So log base 2 of 8. And then we only have one more number to fill in, and that's after the equal sign, equals 3. And using that last rule that I talked about, if it was on the last slide we had log base 2 of 2, any number up here was the answer. Well, that's the case here. We've got log base 2 of 8. I could rewrite 8 to be 2 to the third power. So you can see the 2 is the same as I could replace the 8 with 2 to the third, and the answer is 3. So that's how these logarithms work. But this is the answer for rewriting it in log form. So if we were to try 27 equals 3 to the third power, well, I start with the base again. The base is 3, so log base 3 of 27 equals 3. Okay? So this would be your logarithmic way of writing 3 to the third equals 27. And now sometimes we're given the logarithm and they want us to rewrite it, and so I call it go exponential because now we're taking the log and we're writing an exponent out of it. So we do the same pattern. We start with the base. The base on the logarithm is the small number that's in subscript, reduced lower than the other words, the other parts. So we start with the 5, so I write 5 to the second power equals 25. Okay, So it's always starting at the base, going to the other side of the equal sign, and finishing with the last number that's available. So let's try it down here with the 36. We've got 36, base 6. So base 6 to the second power equals 36. And you can check them again. 5 squared is 25, and 6 squared is 36. Now for a moment I'm going to talk about what a logarithm actually means. And what a log means, if I have log of base 2 of 8. Okay, log base 2 of 8. What this means is you're really asking the question, if you're just looking at this log by itself, the question is being asked 2 to what power, in other words 2 to what power equals 8. That's the real question. If I've got log base 3 of 27, I'm really asking 3 to what power equals 27. That's what logs mean. And again, that kind of works on exponential or going exponential. If you set this equal to x, in other words, what does it equal? I would say 2, the base, to the x power equals 8. Just like I have here. And over here I could say this is equal to x, and then it's really 3 to the x power equals 27. In other words, 3 to what power is 27. So that's what logarithms do. That's what they mean. It's all about the base. And what do you raise the base to? What power do you raise the base to get this number right here? Okay? And that's how we rewrite it in exponential form. So hopefully that kind of clears up what a logarithm means. And now we're going to, in the next lesson, work with more properties with logarithms.